All right, so we're going to go over how to do the pendulum problem, which I believe is number 5 on, sorry, number 4 on 5.5. So it tells you that the pendulum is 2 meters long. That would be a little bit above me. That would be like right here to about the floor. So it's a decent sized pendulum. And as per usual, we're going to draw a picture. So pendulum is just something you swing back and forth. So we'll come over here and swing it there. And yeah, that is 2 meters long. Now, if your problem with this issue is that you don't know what a pendulum is, obviously you need to look it up, or B, you need to kind of play with something that is a pendulum. But the question in this problem is, it starts at rest, and supporting the string has an angle of 25 degrees with the vertical. So I'm going to make a dotted line here to represent the vertical and try 25 degrees. It says, what is the speed of the bob at the bottom of the string? Now we are once again doing mechanical energy initial equals mechanical energy final. And on the last problem, I put elastic on both sides. You can see there's nothing stretching or compressed here. I'm not even going to bother putting elastic in this particular case. Here's the general rule. You put in types of energy that are going to change. If they don't change, you really don't need to put them in. That's why we don't worry about nuclear on both sides of this equation. We pretty hopefully don't want it to change. So we have kinetic initial plus gravitational initial equals kinetic final plus gravitational final. As per usual, we get to decide where our 0 is at. Now, as far as height is concerned, we don't know where the ground is. It doesn't say. So I have no idea what the heck that thing is. So I would say, let's look at our initial and final spot. Well, it tells us that right here, when the bob is at 25 degrees, that's going to be, I don't know, it doesn't matter actually, either our initial or our final, but let's go ahead and say initial, all right? And then right down here at the bottom is going to be our final. Now, when you're confused on a problem like this, drawing a good picture always helps. So I drew a picture at the beginning. Let me go ahead and draw the picture again at the very end. So we've drawn a picture here at the very end, and this will be our final spot. So let's go ahead and say, all right, so I got this guy here, this guy here. Let's set gravitational 0 at just wherever's at the bottom. So let's go to our board. Kinetic initial. Do I have it? Is it moving at the beginning? Nope. So that's 0. All right. Do I have gravitational? Well, yes, because I have some height right here. Do I have gravitational final? Nope. It's 0. And if I fill this out, I go, okay, that's mass times gravity times height initial equals 1/2 mass initial squared. Masses cancel, and we get that the, oops, sorry, this should be final. The velocity final squared, just do some algebra here, multiply 2 on both sides, square root both sides, and you get velocity final is equal to GH. Super simple, except how the heck are we going to figure out what the height is? Well, again, when you're doing stuff like this, let's go to the picture. Where is the height? Well, the height is this right here, right? It's that straight line distance from the 0 straight up to where the object is at. I got this angle over here I haven't used. You heard me kind of drop this hint when I talked about it to begin with. Make right triangles. So I got 25 degrees here. Let me just draw this horizontal line so I make 90 degrees. How might that help? Well, I do know that I could find, with 25 degrees, I could find any side of this triangle. Obviously, this side we already know is 2 meters, because that's the full length. As a matter of fact, that is also the full length of it over here, because it's going to be the same length over there. So I know the whole length is 2 meters. Wait a minute. This distance here is the same as that distance, isn't it? So if I know this whole thing is 2 meters, and I could get the side from the triangle from here to here, that's really going to be this 2 meters minus this piece right here. So my height initial is equal to 2 meters minus, how do I get this? Well, that's going to be trig. Since this is my angle and I have the hypotenuse, I want the adjacent, so that's going to be cosine. So minus 2 meters cosine of 25 degrees. So plug that in. 2 minus 2 cosine 25. And I get that the height initial is 0.19 meters. If you put this in pieces, like this is 2 cosine of 25. So this piece right here is a meter point. My picture is not to scale, 1.81 meters. So it makes sense that's only 19 centimeters or 0.19. So now I just come over here and 2 times g times 0.19 meters, square root of the whole thing. And that gives you the final speed. 2 times 9.8 times 0.19 square root. And we get an answer of 1.93 meters per second. So you can see here that the energy part is not the hard part. And the hard part is kind of putting out a picture like this and creating these right angles to figure out what it is specifically that you need. It's not the only time that you're going to have to use kind of this geometry sort of tricks, I suppose, to figure out some heights or distances that you need. That's that problem. Maybe.